But if we think about graphene for a moment, and that's one that most people and most of your audience will have heard of.
So, for those of folks who are listening right now who are going to come hear you talk, what is the core elements of the technologies you described? In layman's terms, the nanotechnologies, the liquid processing, and things like that.
So nanomaterials are they describe materials that are on the on the atomic scale, if you like, 1 to 100 nanometers thick. But if we think about graphene for a moment, and that's one that most people and most of your audience will have heard of. If you imagine there are, let's take graphite. Graphite is a crystal, and imagine it being a book. We can peel off the layers of that book, page by page, if you like, sheet by sheet, and that's what people call graphene. Okay, so it's single layer structure that if you build it up in lots and lots of layers, it's graphite, right? So if you imagine the graphite has fantastic electrical properties that we want to capture, but when we actually put those into imagine taking that sheet of graphene, those electrical properties are magnified enormously because we have something with a huge surface area, so we can get to the electrical properties straight away, and you have that electrical properties against a ratio of weight and size that is significantly different than when it's in that crystal form. And then if we're able to then control the number of layers that we want to get the electrical performance we need, and then disperse it into a liquid. We use water. A lot of companies will be based on solvents, but we disperse everything in water. Then we can print it, we can paint it, we can soak it into fibers, we can put it into composites. So these nanomaterials come from bigger structures. We're breaking them down into their layers and then building them up again like Lego to get the properties we want, and then putting them into systems so those electrical properties come through into the system.